In this video, I will demonstrate how to use the Parse Example Subset module of Magellan's Compass software. As mentioned previously, Compass runs on a server that I access through the Chrome browser on my laptop. Outside of this tutorial, the internal help bubbles provide for support while using the software. When we reach this module, we are ready to image the mass spec files at their initial resolution for data screening. A key point is that we are working with MS Level 1 data in each file, not MS Level 2 or 3. The aim is to find signals in the MS1 level data that are connected to biological differences between groups of samples. Here we assemble the MS Level 1 data for subsequent analysis. The user-defined parameters in this module include setting the resolution of the parse, which means setting dimensions for binning data along the M/Z and retention time axes. Most datasets are best parsed with large retention time bins and small M/Z bins. Ideally, we would parse the data at maximum resolution, but this presents two problems. First, the sheer number of the resulting data points makes cross-comparison across large numbers of files computationally impossible. Second, high-resolution parsing is confounded by any small shifts in the position of MS Level 1 features on either axis. Thus, we typically set a default resolution at 40 seconds of retention time and 0.2 Daltons in M/Z. This resolution yields 500,000 to 2 million data points per file for cross-comparison. That said, we can increase the resolution for smaller file sizes. The K value is a setting for fully integrated analysis of mass spec datasets with sequencing-based datasets. When this function has been fully developed, we will provide more tutorials on such studies. Finally, the percent to sample field allows the user to determine what proportion of the examples will be subjected to scanning and analysis. For small studies, one can set this value at 100%. However, studies that involve hundreds, thousands, or more examples for each outcome require that the entire dataset be sampled at this stage. When setting percent to sample, it is important that there are sufficient examples to allow biologically relevant signals to appear and to exceed the noise in the data. We also need to account for differences associated with potential subgroups within each outcome category. In this example, comparing 12 proteomics replicates derived from two different NCI60 breast cancer cell lines, 100% of the files were parsed for analysis. In another project with close to 1,000 examples across a time course with 6 sampling events, each one an outcome, 15% of the examples files were chosen for parsing and data screening. When choosing a subset of the files for parsing and analysis, files are randomly chosen from each category until the percent to sample is reached. Thus, creating a duplicate workbook will result in the selection of a new subset of files for the initial parse and analysis, perhaps leading to the identification of unique information. When parsing is complete, the total number of files processed and the number of data points extracted from each file are reported. Up next, I will outline the purpose and operation of the Select Best Data Points module. That module searches the parsed files emerging out of this step, identifying data with high information content.